In this video, we're going to talk about 2.2. This covers our conditional statements. So we talked yesterday about making up if-then statements, where we just turn any statement, any sentence into an if-then. So on Fridays, I like to eat ice cream. I would say if it is Friday, then I like to eat ice cream. So when we do these conditional statements, we now are going to add some variations to the order of the statement and talk about whether or not they're true or false. So always the original statement, we're going to call the conditional statement. And this is just going to be if then, a logical statement that has a hypothesis and a conclusion. So in a problem like this, we would say if hypothesis, and I'm going to switch to red, if hypothesis, then conclusion. And we'll switch to our blue. So that's always going to be our conditional statement. Here I gave an example one. If a dog is a Great Dane, then it is large. So I always like to say we are talking about an adult Great Dane, and this is a true statement. So one of the issues we always have in this unit is just because we write it doesn't make it true. So we're actually going to have a lot of conversation about true or false and counter examples, but here, if a dog is a Great Dane, then it is large. Now, converse. Converse is another variation of our original conditional statement. This is when the original hypothesis and conclusion are switched. So what we're going to have here is we're still going to have an if-then statement, but instead we're going to say the conclusion first. So if conclusion, then hypothesis. So if I write this out for our Great Dane example, we could say, if a dog is large, then it is a Great Dane. So if a dog is large, lots of writing in chapter 2, then it is a Great Dane. So remember what we just said, just because we write it doesn't mean that it's true, so we've got to think about this one. Is it true or is it false? So what we'd have to do is think, are there any counter examples? So are there any dogs that are large that are not actually Great Danes? So a counter example, this hypothesis has to be correct, but the conclusion has to be wrong. So here I would say false, and I want you guys to write in what type of a dog would make this the counter example. So I'm saying false, and I'm going to pick a German Shepherd. But you guys write in whatever you think would make that a false statement. Now, the second type of variation on our original conditional statement is the inverse. The inverse is the negative form of the conditional statement. So in this one, we are not going to change the order like we did with the converse. We're actually going to say, if not hypothesis, then not conclusion. So I'm going to go and write this stuff in. If not hypothesis, then not conclusion. So for this one, and hopefully I can make this fit. We're doing a lot on this page. I'm going to draw a line here just to separate it out. All right, so our statement now is going to read, if not a Great Dane. So if a dog is not a Great Dane, then it is not large. So notice I didn't change the order in this case. We still have Great Dane first, large second. Hypothesis to conclusion, what changes are these not statements. So we have the not in here in front of both that both go into our conditional statement. So again, if we talk true false here, I'm going to say for the same reason, this one is false. If a dog is not a Great Dane, so think of all the different dogs that are not Great Danes. Up here I said German Shepherd. You said something, so if I said, okay, I'm talking about a German Shepherd, well then the conclusion would say that it is not large. Well, that's not true. A German Shepherd is not a Great Dane, but it is a large dog. So that's what makes the inverse a false statement also. So then if we do the last one, the contrapositive switches up everything. So the contrapositive says when the original hypothesis and conclusion are switched and made negative. So we're going to have if not, then not. So we've got the nots in there, but we're actually going to have conclusion first in this one. So everything gets changed in this. Then not hypothesis. So when I go to write out this statement, I would say if a dog is not large, then it is not a Great Dane. That got a little messy in there. I can do better than that. Not a Great Dane. So again, let's talk our counterexamples. So for our counterexamples, I would say if a dog is not large, well, so I have to think of a dog that is not large. So you could say a Chihuahua, you could say a miniature poodle. I don't know enough dogs, but it's definitely not going to be a Great Dane, right? If a dog is not large, it means you have a small dog. If you have a small dog, then it's definitely not going to be a Great Dane. So this is actually a true statement. So notice the conditional statement was true. The converse and inverse were false, but the contrapositive statement was also true. All right, so this is what we just talked about. Just because a statement is written does not make it true. So we're going to go through and write out one more example. This one we start with a statement. Soccer players are athletes. We are going to say that that is a true statement. All right, especially when we write this out. So I'm going to say if, and I'm going to do this with yous, if you play soccer, then you are an athlete. So let's take a second and make sure we're good on the vocab here. This is the hypothesis. And this is the conclusion. So if you guys remember from the previous page, converse is when we just flip them. Converse has no nots in it. So what we're going to change this to say instead is if you are an athlete, then you play soccer. So let's take a second to think about whether or not that's true. And if it's false, we want to have a counterexample. We already said we're saying this one is true. This, I'm going to say it's false. You could play any sport, right? If you are an athlete. So think of a sport you think athletes play. Baseball, football, lacrosse. All of these are other sports that a person could play. Now, the inverse is when we put the nots in. So when I go to do the inverse, we're going to have if and then. That's never going away. But now we keep the order the same. So if you do not play soccer, all right, then you are not an athlete. And I'm going to change my colors so they work out. So if you think about whether or not that one's true or false, well, here we would think, who wouldn't play soccer? And so you might say to yourself, well, not all football players play soccer. Not all baseball players play soccer. So for the same reason that the converse was false, we could use a similar counterexample to say the inverse is false. Just because you do not play soccer does not mean you are not an athlete. And so then when we go ahead and write in this last one, we're going to keep that same if-then, but the contrapositive flips everything and puts the nots. So I would say, if you are not an athlete, then you do not play soccer. So let's think true or false here. For this one, I would definitely say it is going to be true. If you are not an athlete, that means you don't play any sports. So if you are not an athlete, then you definitely don't play soccer. You don't play soccer, you don't play basketball, you don't play volleyball, you don't play baseball, you don't play any sports. So this one would be true. So then I want you guys to try this one on your own. So go ahead and write this one in your notes. But then the last thing I want to talk about is this biconditional statement. So a biconditional statement is a statement that combines a conditional statement and its converse if both are true. These use the phrase if and only if. So here I could say an angle measures 90 degrees if and only if it is a right angle. Oops, and I lost my if in this statement. So if and only if it is a right angle. All right. It works both ways. The whole definition of a biconditional statement is you should be able to read it the other way around. So I should be able to say if an angle is a right angle, then it measures 90 degrees. If an angle measures 90 degrees, then it is a right angle. So when we have a statement where it works both ways, you can just write it one time and put an if and only if in. So if we look at the example you have, if today is Friday, then tomorrow is Saturday. Well, if I wanted to write the converse, if today is Friday, then tomorrow is Saturday, that's true. That works. You have to have Saturday after Friday. So if I switch to the converse, I would say if tomorrow is Saturday, then today is Friday. Well, that sounds pretty good too, right? If tomorrow is Saturday, then you guys would know today is Friday. So these are both true, which means we are allowed to write the biconditional statement out. So my biconditional statement, this is the easiest way I like to do these. Take that original conditional and just rewrite it. If today is Friday, then tomorrow is Saturday. The easiest thing to do, cross out the if, cross out the then, and put your if and only if in the middle. IFF is a shortened way of writing this. If and only if. And then read it and